Hey, this is Mr. Mitchell with another video. Today we're going to be talking about scientific observations and measurements. In making scientific observations, several tools are commonly used. In fact, using the word several is probably an understatement. Have a few here. We have the scale, we have the thermometer, and over on this side you can see the microscope and the telescope, and there are dozens and dozens of other tools that scientists use. Now, you may remember from the last video that scientists often will come up with a hypothesis, and that's where these tools come in. In observing and testing their guess or hypothesis, they will use tools and specific data, because you may remember that this data has to be able to be reproduced anywhere in the world. So these testing may not be just this one person testing it. It has to be reproducible. So they use tools to test a hypothesis, and these tools are very, very valuable, especially the data. Now let's talk about continued the data. We have this screen. Whenever you have data testing a hypothesis, you have more than just the number. You have the unit also. Here we have the unit meters per second. Here we have the unit kilograms. You have to have the unit with the number. That's just how you have to do in scientific measurements. And there are units that are common throughout the world. Now think about this. Whenever we measure mass here in the United States, we often go with pounds. But this is the metric measurement of mass, the one that is commonly used throughout the world. You may remember, if we're going to reproduce experiments that are done anywhere in the world, it kind of means we need a common language, a common set of units, you might say. And we have that. In France, because this is in French, I'm sure it must have been in France at some point, we had the International System of Units. And it's called the SI system because it's Le Système International and so on. But when you see of SI units are talking about the standard units that people use throughout the world to test hypotheses. And you can see up at the top we have meters as a standard unit for length. Here we have seconds as a standard unit for time. This A stands for amps, or amperes, which is the standard unit for electric current. There are quite a few things besides just these four. I just picked out a snippet, you might say. Now, of course, for example, kilograms, you might have a measurement that is way smaller than kilograms. You might have something that is in grams or even milligrams. And of course, people will end up using those prefixes, and I think I have some of the prefixes here: kilo, hecto. I think kilo is up here, and you probably have covered those before, but kilo is 1 with 3 zeros, hecto is 1 with 2 zeros, and all the way down to milli, which is moving the decimal place 3 points the other direction. But naturally, these can easily be converted into the SI units. Looking at my notes to see if there's anything I have left out, and I have not. The more specific the measurement, the better the scientific observations. Whenever you're recording observations testing out a hypothesis, you want to avoid just saying something is really hot. You want the specific temperature, like say 125 degrees, and you have to have the unit with it. So let's say 125 degrees Fahrenheit. Now the Systems International is going to be Celsius, but that's an easy conversion if you happen to know the formula. You would avoid saying something like fast, but if something is 8 meters per second, then you have something specific. So generally, that's exactly what scientists try to do. They try to avoid generalities and find specific data. Why don't we go to this word here, variable. when scientists test a hypothesis, they're looking for changes. A factor that is a change is called a variable. The word vary, V-A-R-Y, means to change. And I think it's probably time for an example. Say you have an experiment where you see a feeder and lots of different kinds of birds come to that feeder. And your hypothesis is something like, oh, certain birds come in the morning and certain birds come in the evening. Certain color birds, or certain species, I guess I should say. But say you have that hypothesis. There are lots of variables. Remember, a variable is a factor that can change. What are some factors that can change? The kind of food you put out is a factor that can change. The time of day is a factor that can change. The size bird feeder is a factor that can change. Whether you put it in the sun or in the shade is a factor that can change. There are just many, many, many different kinds of variables. But to have a good solid experiment, you want to have not so many variables that change. Here we have a couple of different terms for variables up here. This is a type of variable that can change. It's called an independent variable. Now, a dependent variable can change, of course, but the type of variable that typically is not changed by the scientist is the dependent variable. So the scientist changes the independent variable. The dependent variable is something that can be changed, but not by the scientist. Let me give you an example. Let's say we have what kind of bird is at the feeder. That's definitely a variable, but it doesn't depend upon us. It just depends upon the other factors. So let's say we control something. This is the thing we can change as the independent variable. Hey, why don't we change what kind of food you put in here? This looks like sunflower seeds, but let's say we put some pumpkin seeds in there. That would be the independent variable. The independent variable, the pumpkin seed, the change to pumpkin seed, might change what kind of bird comes here. What kind of bird comes would be a dependent variable. See, the independent variable influences the change, and that means that you might have a change in something else like the dependent variable. So the independent can change the dependent. What's another independent variable we could have? Maybe we painted the birdhouse a different color, and we saw if there are different species of birds that came. It may have changed the dependent variable. It may not have changed the dependent variable. But the independent variable is something that we change as a student or as somebody who is conducting the experiment. Now, a scientist must be careful not to have too many variables. If you have lots of different changes that you make, then it's hard to tell what's the determining factor. If you change to pumpkin seeds and you end up changing the color, and if you end up putting it in the shade instead of the sun, you can't tell which variable is the one that affected what kind of birds come in. So you would have all the variables the same except the one you're testing. So let's say you put pumpkin seeds in here and the same types of birds come to the pumpkin seed. That's when you would change variables and you would try to determine what is affecting what birds happen to be coming. So a scientist must be careful not to have too many variables. In most cases, the observer should test how the independent variable affects the dependent variable. That's one thing that you change, hoping to see if you have the change in the dependent variable. So all the other factors must be controlled. A controlled variable is something that could be changed but is kept the same during observations. I mentioned like you would only change, for example, the type of seed that's in here. There's lots of factors that could have changed. The ones that you didn't change, we mentioned the color of the birdhouse, whether it's in the shade or whether it's the sun. Those are often called the control. The controlled variable is the control. Now, often you will find this like you do here. You have here one plant and another plant. One's labeled control, one's labeled experimental. The experimental will have that one independent variable that's different. The control will not have that independent variable different. So you could have a control per se with this, another feeder with the sunflower seeds instead of the pumpkin seeds. So that's what a control is. It's a variable that you control, and sometimes scientists have it where the control is a separate thing there. Nothing has changed. And that way they can kind of get some pretty good observations from that. Oh, what else could be controlled? Time of day, temperature, amount of noise around. There's lots of different controls you could happen to have for here. And finally, the term trial. No, we're not trying to convict someone on some murder rap here. A trial is one repetition of an observation or experiment. So if you go out one day, change one independent variable like the seeds, and make your observations, that is one trial. Now let me tell you, scientists usually do not stop with one trial. In fact, you're probably not a very good scientist if you do stop with one trial. They have many trials, many trials. So instead of one day where you change the independent variable, you change that same independent variable for many, 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 many days. And that way you can be sure what is doing the changing, that it's not just some accidental factor which is making things change. And many times what scientists will do when they get the data of, for example, how many different kinds of birds came or how many specific species of birds came, they'll take all the data and average it up, and they may even throw out the ones that look like outliers. Those are the ones that are obviously really high or really low. So that's what a trial is. Hopefully you can have learned something about trial, control, and the different kind of variables and tools for measurement in a hypothesis.